Learn about a double replacement reaction where the driving force is a solid or a precipitate being formed. Taking a look at this reaction, if we combine lead ions and we mix them with iodide ions, it forms an insoluble precipitate called lead 2 iodide. And when we do that, it actually forms this yellow substance that is solid and insoluble. On the microscopic level, what happens is these ions combine to form the solid, which is located right here, and these guys, which do not react, are called spectators. Taking a look at this reaction, will a precipitate form when an aqueous solution of calcium chloride and potassium phosphate are mixed? Go ahead and pause the video and do a double replacement reaction figuring out the products. When you do the double replacement reaction, remember that the cations always switch spots, and they do not take with them the subscripts. So you have to do BIPs in order to figure out the correct formulas. When you do BIPs, it should come out this way, where calcium is 2 plus and phosphate is 3 minus. So the common factor is 2, and the common factor here, the common factor is 6, so therefore we have to have a 2 coefficient, and since it's 6 here, we have to have a 3 coefficient here, which is the reason why we have a coefficient there of 3 and a coefficient of 2 right there. Same thing with potassium. Potassium is plus and chloride is minus, so therefore we don't have any coefficients, and that's why it looks that way. Now our next question is, with these products, are they insoluble or soluble in water? If they're insoluble, that means that they're solid. If they're soluble, that means that they are aqueous in solution. So how do we figure this out? Well, we take a look at this chart here, and it's called the solubility chart. You need to become familiar with how to use this. So taking a look up here, compounds containing these ions are soluble, which means that they are aqueous in solution. And it says unless, which are the exceptions, which make them insoluble or solid. Same things down here. Compounds containing these ions are insoluble, so therefore they form precipitates, unless, which is the exception, soluble, therefore they're aqueous. Now let's take a look at our two compounds here for the products. We have calcium phosphate. Okay, so I'm looking for calcium or phosphate. Well, taking a look here, calcium anything that has phosphate in it, okay, is considered a solid. And notice down here there's no calcium, so therefore this is going to be a solid. The next compound I have is potassium chloride. Anything with potassium is aqueous, and anything with chloride is aqueous, unless I have these, and it's not the case, so therefore I'm aqueous. So, will a precipitate form? The answer is yes. So this is my solid, and this is my aqueous. How do I write this? Well, it looks like this. Notice the solid goes right after, and notice the aqueous comes right after that compound there, that compound formula. Now, what we're going to do right now is we're going to do the same thing that we learned with acids. except we're going to apply this to the double replacement with precipitations, where we do the molecular formula, the total or the complete ionic formulas, and finally the net ionic formulas. Taking a look here, this is our equation, but it's completely unbalanced. So when we do a molecular equation, we have to balance it, and it looks like this. Okay? Notice the 3 and the 2 and the 6. Okay? You need to become more familiarized with balancing equations because this is important now. Taking the total ionic equation or complete ionic equation, again we have to do BIPs for all the aqueous compounds. So I have to do BIPs for this, I have to do BIPs for this, I have to do BIPs for this. And I leave this one because it's an A solid. Okay, and I cannot forget about multiplying the coefficients by distributing out how many ions of each are in the compound. So when I do that, 3 times 1 is 3 calcium. 3 times 2 is 6 chlorides. 2 times 6 is 6 potassiums. 2 times 1 is 2 phosphates. I leave that together. 6 times 1 is 6 potassiums, and 6 times 1, which is 6 chlorides. Now, the last equation which I'm interested in is the net ionic equation. And I take a look at all my ions that have to do with the formation of my solid. Okay, here's my solid. So I'm looking for calcium, and I'm looking for phosphate. All the others are spectator ions. So I take all the spectators out, and I just drop them down, and this is what I get as my net ionic equation for this reaction. Here's another example. If I take an aqueous solution of calcium nitrate and I mix it with sodium chloride, will a precipitate form? So I want you to pause, and I want you to try to figure out what the products are by doing the double replacement of the cations and doing BIPs. So your equation should look like this, where the cations switch spots. Okay? And when I do that, I have to make sure that my charge is balanced to 0. So calcium, again, is 2 plus. Chloride is minus 1. I need 2 of these, so that's why I have this there. Sodium is plus 1. Nitrate is minus 1. So therefore, I have no parentheses and no subscripts. The next step is to figure out whether or not these products are aqueous or solid. So I refer to the chart. Calcium chloride. Well, anything with chloride is considered aqueous. So therefore, calcium chloride is aqueous. Okay, the next one is sodium nitrate. Well, anything mixed with sodium, okay, is considered to be aqueous, and also nitrate. Okay, so sodium nitrate is also aqueous. Now, we still have to do all 3 equations. Okay, so taking a look there, will it precipitate form? The answer is no. Both of them are soluble, so therefore both of them are aqueous, and no precipitate forms. Taking a look at the equation, it looks like this. Now, I still have to go through the same motions. Okay, molecular equation has to be balanced. Well, I have one calcium there, one calcium there, two nitrates, one nitrate, so I'm going to put a 2 right there, one sodium, but I have two sodiums on this side, and two chlorines and two chlorines, so now I'm balanced. So it looks like this. The next step is to do the complete or the total ionic equation. Again, BIPs for all aqueous compounds and distribute the coefficients by multiplying through with the subscripts. Okay? Well, all of them are equals. So therefore, I'm just going to do BIPs for every single one of these compounds here. And it looks like this. Notice I have two nitrates, which come from there. I have two sodiums, which come from there. Two chlorines, which come from there. Again, two chlorines, which come from there. Two sodiums, which come from there. And two nitrates, which come from there. Finally, I set up my net ionic equation. Well, since there's no solid, gas, or liquid water formed, then all of them are spectators. And the way we say this is there's no reaction. Please go ahead and work on your double replacement reaction worksheet now.